Hey kids, welcome to lesson 3.6, equivalent Boolean expressions, De Morgan's Law. What if you heard a rumor about a senior at your high school? Kids shouldn't get into rumors, you know that. And then you heard that the rumor wasn't true. It wasn't a senior at your high school. Which part of a senior at your high school wasn't true? Maybe that they weren't a senior, or maybe that they didn't go to your high school. You could write this as a logic statement, like below, using negation. That's an exclamation point in the and operator, since both parts have to be true for the whole statement to be true. If you look over here, we have our not operator here, A and B. A is a senior, B is at our high school. That means it is not true that a senior and someone at our high school. That's just saying, kids, this is a way to write it out. In this lesson, you will learn that De Morgan's Law, which simplifies statements like this. We know that a not operator at a senior at our high school could mean a not a senior or not at our high school. Let's learn a little more about De Morgan's Law. Kids, I know you're just wincing at my pronunciation of this, but D, there's a whole bunch. We're just going to roll with my poor Pittsburgh accent here, kids. De Morgan's laws were developed by Augustus De Morgan in the 1800s. They show how to simplify the negation of a complex Boolean expression, which is when there are multiple expressions joined by an and or, such as x is less than 3 and y is greater than 2. When you negate one of these complex expressions, you can simplify it by flipping the operators and end up with the equivalent expression. De Morgan's Law states that the following equivalencies. Here's an easy way to remember Morgan's Law. Move the not inside and becomes or, and move the not inside or becomes an and. This is just saying, kids, not A and B is the same thing as saying not A or B. And that's just a way to simplify it there. Not A or B is not A and not B. Just remember that. I'm pretty sure you're going to end up seeing that on a test somewhere. In Java, De Morgan's Law are written with the following operators. And this right here is just the equivalent of what you see right here. Going back to our example above, not a senior at our high school is equivalent to not a senior or not at our high school using De Morgan's Law. That just means it's breaking it down just like the rumor we were talking about above, kids. Maybe it's not a senior or maybe it's not somebody in the high school. That's why you shouldn't spread rumors to begin with. You can simplify negated Boolean expressions that have relational operators like the greater than or less than or equal to. You can move the negation inside the parentheses by flipping the relational operator to its opposite sign. For example, not C equals D is the same as saying C does not equal D. An easy way to remember this is to move the not flipped to sign. Notice that the equal becomes the not equal and the greater becomes the less than or equal to. Just means we're flipping signs here, kids. For my visual learners, not C equal to D is the equivalent to C is not equal to D. So it's just flipping stuff around as we go. Again, this is just a helpful little table to simplify things as we go forward. Although you do not have to memorize De Morgan's Law for the CSA exam, you should be able to show the two Boolean expressions are equivalent. One way to do this is by using truth tables. For example, we can show that not equal A and B is equivalent to not A or not B by constructing the truth table below and seeing that they give identical results for the two expressions. The last two columns in the table are identical. This is just showing that these are the same thing. So A and B true, you get the same expression by writing it this way or by writing it this way. Remember, flipping it around, kids. Often you can simplify Boolean expressions to create equivalent expressions. For example, applying De Morgan's law to x is less than and y is greater than yields x is less than 3 or y is greater than 2, and the not operator on both of those sides. So we're just flipping it like above. This can be simplified further by flipping the relational operators to remove the not, so that not x is less than 3 or not y is greater than 2. And that is simplified to x is greater than or equal to 3 or y is less than or equal to 2, where the relational operators are flipped and the negation is removed. These two simplification steps are seen below. So this is just taking our simplification and making it even more simple. So if you're writing something like this out, this is probably a better way to write it. So you can see we're just flipping it and changing the Boolean expression to or. For what value of x and y will the code print true? Try different values of x and y to check your answer. We have our method here. We have an integer x, which is equal to 2, an integer y, which is equal to 3, and we're going to print out if x is not greater than 3 and y is not less than 2. So what this is saying, we want x less than 3, but since it's a not, we're flipping it here. So what numbers could we do? Well, anything above 3 really should do it for x. So I'm just going to put a 4. And for y now, it's going to be anything less than 2. A 1 should work. A 1, not a 31. If I hit save and run, you'll see true, it's been passed. So I could put 0, and then any number greater than 4 would also satisfy these conditions. What is printed when the following code executes and x equals 4 and y equals 3? We have our integer x equals 4 and y equals 3. If x is less than 3 or y is greater than 2, well, we have an or and a not. Well, kids, so this is saying if x is not less than 3, so any number greater than 3, or y is not less than 2, so anything less than that, it's going to print out first case. Otherwise, it's going to print out second case here. Well, the first expression, 4 is greater than 3, and we want x not to be greater than 3. So on that case, that is going to print out true. Y, which is 3, 3 has to be less than 2, because 3 is greater than 2, and it's saying y is not greater than 2. Well, that's false. So that's going to print off the second case. What is printed when the following code executes and x equals 4 and y equals 3? Well, we have an integer of 4 and 3. X is greater than 3 and y is greater than 2. Well, on this one, again, we have is 4 greater than 3? Yes. So that one is true. Is 3 greater than 2? No, but that's not. Is 3 not greater than 2? No. So both of these conditions are true here in this case. So we should print out the first case. Kids, for this programming challenge here, I'm going to be referencing a sheet. That sheet is this one here. Unit 3, Lesson 6, Programming Challenge, Truth Tables, POGAL. Just keep that in mind, kids. Number 1, complete a truth table for the Boolean expression x equals 0 or x is greater than 1, but that's a not. So the opposite is this set a positive or negative numbers. Is the expression true when x is positive? or is it true when x is negative? You can try out the values when x is 1 or -1 or 0. Note that 0 is not positive or negative. You can try running the code below to check your answer. So we have a little check down here we can use if we want to, but I don't think we're going to need it, kids. Let's see. We have our truth table over here. And what do we got? Well, x is equal to 0. X is greater than or equal to 1. And then if P or Q, so if P is equal to 0 or x is greater or equal to 1. So right now they're both true. So this one's going to make that one true. And if that one's true, not being true, if just one of these or both of these are true, it's going to be false. So if x is not equal to 0, but you can see x is equal to 0, so we have a false right there. True, false, well, only one of these have to be true, kids. That's a true. Now one of them is false, so the entire thing is false. Well, this is just the opposite, so this one is true, kids. Again, just one of them needs to be false. One of them is. This right here, if neither one of these is true, then that's false. But remember, if any of these are true, it's false. So if nothing here is true, then this one is true because it's the opposite. We have a little part to answer still. Is the set of positive or negative numbers? Is the expression true when x is positive? Is it true when x is negative? So this one right here is really describing negative numbers. We should only get a true statement if it's negative. Let's go down here and try it out. And what we can do is we can just run our negative number there. So let's run it. And it is true. So this one only should work for negative numbers. That means if I put just a 1 here and run, I should get a false. Or 0, because 0 is a positive, kids. It's going to get a false. So in this situation, any negative number should give me a true. Complete the truth table for the Boolean expression. X is not equal to 0 and x is not greater than or equal to 1 is a set of positive or negative numbers. Let's go to our table down here. If x is equal to 0 and x is greater than 1, well, kids, this is saying it's not either of those. So we have to put a false for both of those. If x is not equal and it is not greater than 1, well, we're going to put false there because they're both false. We come down here. Is x not equal to 0? Well, if it's true here, kids, that has to be false. If x is greater or equal to 1, well, if it's not that, then kids, it's true. We still have one of these, so this has to be false. We come down here. If x is not equal to 0, well, this one becomes true. If it is greater than 1, well, this one's false. And again, same thing, false there, kids. If neither x is greater than 0 or not greater than 1, so that means it is less than 1 and not equal to 0, that's going to satisfy both of these conditions. We have an and, so this one's going to be true. Is this set of positive or negative numbers? Well, kids, this describes negative numbers. And notice that the last column is the same as the one above. So this is negative numbers for that one. Complete the truth table for the Boolean expression x is not equal to 0 and x is less than 1. Is this set a positive or negative number? If x is not equal to 0 and x is less than 1, if both of those are true, well, we don't want x equal to 0 and we don't want x less than 1. Well, kids, that's going to be true. Now, because we have an and here, if just one of these are false, well, it's going to be false. Same with this one, kids. And then finally, if they're both false, well, they're going to be false. And this, kids, this describes negative numbers. Number 4, are the 3 Boolean expressions equivalent, why or why not? Well, kids, expression 1 and 2 are equivalent since P and Q in them are the same, and the last column of their truth tables are the same. Expression number 3 is also equivalent to 1 and 2 because notice that its P's and Q's are the opposite of P and Q in expression 1 and 2. And in the last column, it's the opposite of expression 1 and 2. They're also equivalent with De Morgan's law. And that's the one where we flip it, kids. So it's just a practical way of showing that. Kids, let's see this actually practically written out. Here's Morgan's law right here. Notice how we move it inside and then we flip it. So just a practical way of seeing De Morgan's law. Pretty neat, kids. Kids, we're going to go ahead and test this code here. And really, all we're doing is just copying and pasting these equations in here. So we're going to do our system.out.println quotation marks. Well, what are we copying here? Well, kids, it's just this expression right here. So I'm just going to Control C, Control V that, and our quotes, parentheses, and our semicolon. We're going to do the same for the second one. Println, put our quotes there. Which one do we need? This one, kids. Control C. We're going to come down here. And our parentheses. And our semicolon. Now, when we print it off, we should get our truth tables. So let's hit save and run. True? Ooh, kids, you don't want my quotes. I want it to run the code. Silly me. We don't want it to print out exactly. Let's hit save and run. There we have our true, 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 true. So that's how we test our things. And a good reminder, the quotes will print out exactly what's in there. And to run what's in there, we don't need our quotes, but we still need our parentheses. That's it, kids. That tests our code right there. Which of the following is the same code below? So we're looking at X is not 2 and Y is not 4. So remember, we do our flipping and our sign. So or becomes and becomes or, and then the less than becomes the greater than or equal to. Well, there's only one that fits that, kids. Well, let's see. Which of the following is the same code below? X is not equal to 2 and X is not greater than 4. So remember again, we are switching things around. It is the or, equal becomes not equal, and then this becomes greater than or equal to. Only one that does that. That's that one right there, kids. Which of the following is the same as the code below? We have a not operator here again. So X is not equal to 5 and X is not equal to 7. So that means X is equal to 5 or X is equal to 7. Only one that does that. Which of the following is the same as the code below? And we have our not operators. So we have to flip stuff around again. And then we have X is less than or greater than equal to 5 and Y is greater than 7. So we're going to flip stuff around, kids. So that means X is just going to be greater than 5 or X is going to be less than or equal to 7. Only one that does that, kids. Well, that's D. Which of the following best describes the value of the Boolean expression A and B or A? So this is saying here, kids, A and not B or A have to be true for this to go through. Pretty much contradicting itself. So this one is always going to be false because it can't be and or. And especially it can't be not. So it's going to be and. So This one is always going to be false, since it can never be true, kids. A and not A can never be the same. We have our summary here, kids. De Morgan's law can be applied to Boolean expressions to create equivalent ones. Not A, and B is equivalent to not A or not B. Not A or not B is equivalent to not A and not B. A negated expression with a relational operator can be simplified by flipping the relational operator to its opposite sign. So this is just what we did above, kids. Not C equals D is the equivalent to C does not equal D. And the same as it goes down to the chart. So remember, kids, flip the ands and ors, the signs, and the equals. Truth tables can be used to prove the two Boolean expressions are identical. Equivalent Boolean expressions will equate to the same value in all cases. So that's it, kids. That's lesson 3.6 in De Morgan's law. Hopefully, my poor pronunciations did not make you cringe too much out there. Blame that poor Pittsburgh upbringing. Yins out there who are from the area know what I'm talking about. Well, that's it for this video, kids. If you have any questions, let me know. Otherwise, I'll see you on the next video. See you later, kids. Bye.